Tēnā koutou katoa. E te mana whenua, tēnā koutou. Ko Tapue Nuku te maunga, ko Awatere te moana. No Blenheim o, ko Evie taku ingoa, he akonga o ai te wharanui o te Waitaha. No rewa, tēnā koutou, tēnā koutou, tēnā koutou katoa. ResDev Consultancy has been engaged by the University of Canterbury to carry out a concept design for the continued development of Redmondsburg subdivision along Cashmere Road in Kennedy's Bush, Christchurch. A concept development of stages 4 and 5 is required, where stages 1 and 2 have been complete and stages 3 is currently under construction. The site is a hillside development for the lower slopes of the Port Hills, aiming to provide a unique semi-rural neighbourhood for residents. The client wants 80% residential, 10% commercial and 10% recreational land zoning and construction to be complete within 1.5 years. Design emphasises a low environmental impact. The proposed subdivision consists of bringing the total number of residential lots up to 82 and providing 17,000 metres squared of commercial zoning. 27,000 metres squared of the central gully shown here, occupying the centre of the subdivision, will be developed as recreational land. The recreational land will be developed into a walking track to provide a relaxing but physically challenging experience for residents. Sustainability will be promoted through turning the areas in the gully into a restorative park, which could be maintained by Mana Whenua or the Christchurch City Council.
Tēnā koutou katoa, e te mana whenua, tēnā koutou. Ko Piko de Oro, te monga, ko Tuiahan te awa. No Philippines, ako te puna, ko Julian Maranan, tako ingoa. He akonga o I te whare wananga o Waitaha. No reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. Large amounts of cut and fill are needed to allow for the construction of the transportation system. Cut and fill to regrade is usually the first choice of stabilization method as its effect is immediate and is the cheapest option. Through cut and fill, the land can be recontoured. The slopes in many locations of the site exceeded the allowable 12.5% gradient for roads, resulting in large volumes of earth that needs to be moved. A total of 60,000 meter cubes of cut and 26,500 cubic meters of fill are required for the construction of the main carriageway, along with the lanes and private lanes. Areas of risk for both slope stability and earth moving, due to the site being mainly composed of loess soils, will be supported through the use of timber pole retaining walls. Retaining walls will be installed where earth moving occurs. The timber poles used are to be constructed from 200 mils diameter radiata pine, spaced 1.2 meters apart. Geotextile fabrics will be incorporated into the retaining wall to provide additional strength and drainage. Due to the soil being potentially contaminated from its prior use as a rural farmland, the excavated soil cannot be reused for fill and must be disposed of appropriately. NES soil consent is needed. Consent conditions may include permitted site activities, site remediation, site mitigation, and site management regulations. The soil removed will be treated or disposed in the appropriate facility or landfill as per the NES soil consent.
Tēnā koutou katoa, e te mana whenua tēnā koutou, ko Montmartre te manga, ko La Seine te awa, no Scotland aku te puna, no France o, ko Emile Bruce taku ingoa, he akonga o I te whare wananga o Waitaha. No reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. An integrated transportation assessment is required for the site due to the size of the development. The assessment is to be undertaken with special consideration towards pedestrians and cyclists, The development will be connected to the Quarryman's Trail cycleway via Sutherland's Road. The route will start at the intersection of Kitchener's Knoll Road and Cashmere Road and progress left towards Sutherland's Road. The cycle path will be two-way and separated from the main movement lane by 1 metre and will extend onto neighbouring farmland. The cycle path is located such that it only follows right-hand turns and will connect to the existing two-way cycle path for Quarryman's Trail. Signalised crossings will also be implemented at the intersection of Cashmere and Kitchener's Knoll Road to improve cyclist safety at the intersection. Public transportation can be extended past the bottom of the subdivision with two possible route extensions. The first option is to extend the 100 bus line to Cashmere Road, and the second option is to extend bus route 145 to the same point, but offer transit on every second bus. These buses will stop at the bottom of the slope, with bus stops on either side of the road, outside the subdivision, to allow both extension options to service the development. Further bus stops will also be evenly spaced out along the remainder of the routes. The carriageway width for the lanes and private lanes will be increased to 6 metres to allow consideration for firefighting vehicles. 25-metre diameter roundabouts will be constructed at the end of each lane to allow for adequate turning space for the firefighting vehicles. The carriageway for the main road will be increased to 9.2 metres, allowing for 1.8 metres of parking space on either side of the road. The speed will also be limited to 40 km per hour on the main road, 20 km per hour on the lanes, and 10 km per hour on the private lanes. For pedestrians, a 1.5 metre wide pathway is provided along the main carriageway, but for the lanes and private lanes, the carriageway is shared due to the low speeds in traffic. Roundabouts will be installed in the southern and eastern part of the development to help mitigate hazards resulting from poor sight distances due to elevation changes, along with traffic mitigation for the commercial zone. These roundabouts will have a 22.6 metre radius to allow for the safe passage of firefighting vehicles. The use of bright street lighting, clear street names, assigned parking spaces, and appropriate window facings for residential units are also recommended as part of the crime prevention through environmental design initiative.
Tēnā koutou katoa, ko Tararua te maunga, ko Wakanai te moana, ko Ngāi Tahu te iwi, ko Parapara umu o, ko Robert Clement taku ingoa, he akonga I te whare wānanga o Waitaha, nō reira tēnā koutou, tēnā koutou, tēnā koutou katoa. The stormwater treatment system on the site is currently a temporary solution with the use of stormwater tanks on individual lots until the completion of the Christchurch City Council stormwater treatment facility on Cashmere Road. The lower sill that encompasses the majority of the site is susceptible to erosion and has low permeability, making soakage not a feasible option for stormwater treatment. This, along with steep slopes resulting in higher flow velocities and an increase in impermeable surfaces, resulting in increased runoff volume, is a major issue with the current system. The proposed solution is the construction of a stormwater detention basin situated at the bottom of the central gully, where the slope is at its shallowest. This also allows for future expansion up the gully if larger volumes of storage are needed. The capacity of the basin is designed to be 3,600 metres cubed, with a maximum depth of 1.5 metres. The edge of the basin will be supported by embedded rocks and vegetation to improve stability, along with amenity value. In order to construct the basin, an extra 51,600 metres cubed of earth will need to be excavated, along with the removal of several trees and low-lying bush from the gully. The basin will discharge via an outlet into an existing stormwater culvert, which connects to the council stormwater system. Special care is to be taken in the design of the outlet to prevent coarse particles from being taken downstream, along with the ability to increase flow rates in the case of an emergency. The lots will be connected to the basin by 1,410 metres of subsurface piping, where groups of lots will have their own pipe to provide resilience and redundancy to the system. These pipes will be buried under the carriageway until diverted into the gully. Rain gardens will act as the inputs to the subsoil drainage, along with roadside sumps with 910 metres squared of rain gardens across stages 4 and 5 being required. The placement of these gardens is in the lots is at the discretion of the lot owner, but is highly encouraged. Stormwater tanks are recommended in order to collect roof runoff with size dependent on the residents. In terms of environmental effects, large amounts of excavation and soil movement will be required for the stormwater basin along with the piping system. This will create a large amount of noise for the residents in the area. This inconvenience will be minimised through work hour restriction, which is also a constraint of the resource consents. Many trees and low-lying bush will be being removed when the basin is excavated, which may reduce the amenity value of the central gully as well as slope stability. The fact that some of this is already out of sight and the implementation of an aesthetically pleasing water body should hopefully be enough of a counterbalance. Since the water body is 1.5 metres at its deepest, this can pose a drowning hazard for small children and those who do not know how to swim, along with the dangers of the steep slopes resulting from excavation. To mitigate these hazards, the basin will have a fence around the edge of it and the slope access shall be restricted. The vegetation in the basin should also help with this, as it should act as a natural barrier. Signage will also be used to inform people of potential risk. Another hazard to consider is contamination. This can be a result of potentially contaminated land or contaminated runoff from the lots. This should hopefully be managed through the use of rain gardens and vegetation in the basins to attempt to deal with the contaminants before they become an issue for the main CCC system. The estimated cost of the stormwater system is around 2.1 million New Zealand dollars, which covers the cost of pipe laying, excavation and tree removal. This value is only indicative of the magnitude of the expected cost and should not be used for final designs.
Water supply is arguably the most important aspect of subdivision design. Our solution is an on-demand reticulation system sourcing water from CCC wells, which are potable and provide a sustainable drinking water source. Connection to Sutherland's One Reservoir, the grey circle in this figure, is the most feasible option. Building a concrete reservoir above the site on a flat section of land, as shown by the blue circle in this figure, will provide resilience and promote future growth beyond stages 4 and 5 of Redmond Spur. The green lines in this figure indicate CCC mains pipes, and blue lines indicate the new mains network to be installed. Throughout the subdivision, a minimum 400 kilopascals of pressure will be achieved, and 15 fire hydrants are needed to comply with firefighting standards in New Zealand. Water will be drawn from Sutherland's reservoir to a 250 metre cube concrete storage by a dry mountain centrifugal pump. From this storage tank, the water will be circulated using gravity reticulation to each lot. The system is designed such that it is a looped network to prevent stagnant water and chlorine buildups. Within each turnaround, area water supplies will be looped and fire hydrants should be placed, allowing the lines to be flushed. Rainwater recycling tanks are suggested for part of the commercial zone to allow the reuse of water for non-drinking purposes. 2 pipes will also be used per pipe cavity to ensure resilience in the system. The main environmental impact of this proposed solution is the construction footprint that will arise from excavating trenches for the pipes. This will be mitigated by ensuring pipe placement is such that all sluice gates, valves, fire hydrants and other surface boxes are able to be easily reached to reduce the extent of future earthworks during maintenance. Polyethylene is also a porous material, and further geotechnical research is needed to determine whether this poses a threat to contaminating the water supply source. Total construction costs will be around $100,000 for materials and approximately another $500,000 to implement the pipework.
Tēnā koutou katoa. I te mana whenua tēnā koutou. Ko Mount Wellington te maunga, ko Hauraki te moana, no Aotearoa aku te puna, no Tamaki o. Ko Finn taku ingoa, he akonga o te whare wananga o Waitaha. No reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. The existing pressure sewer, which connects to Christchurch City Council network along Cashmere Road, will be extended to stages 4 and 5 of the development. Each lot will have an E1 grinder pump, which will feed through 40mm diameter lateral PE pipes into the main 100mm diameter PE pipes buried under the berm of the subdivision roads. Each pump system will have a high density PE holding tank of approximately 900 litres and a PC pump and a cutter to break up the waste. Each grinder pump will also utilise one-box monitoring technology to develop a smart pressure sewer system. This will allow for monitoring, prioritisation of major issues, and a reduction in required maintenance and costs. The system will have a temporary end installed at the upper boundary, which will terminate at a manhole. Doing this allows for the potential development of alternative systems in the future. G13 AS2 grease traps and catch baskets are to be installed in the commercial zone to prevent oils and oily solids from causing issues from entering the sewer network. The main alternative solution considered was a gravity sewer reticulation network. However, this design was found to be too dependent on the topology and gradients of the site. It was also less practical to adopt a new wastewater solution considering the existing development. In terms of environmental impacts, exfiltration was the main concern associated with pressure sewer networks. When ground movement occurs or other damage is caused to the system, exfiltration or overflows may occur. Leakages from wastewater sewers are a typical consequence of pipe damage and can cause contamination of groundwater and soil. The use of dense PE pipes, as in the design, reduces this risk. The cost estimation for the installation of the pressure sewer network at Redmond Spur was approximately $3.3 million. This included the cost of piping for around 3,500 metres and the cost of a grinder pump system.
A predicted program of works is shown in this slide for our subdivision design. The estimated total project cost is $10.5 million, which includes GST and a 30% contingency. For maintenance, a 0.1% total cost per year, about $10,000, should be allocated. This will only be needed until the systems are handed over to the council upon completion. The feasibility of this project is found to be 45.8%, indicating a very favourable return.